So right here I have a vial of saturated alum solution, and as you could tell there are no crystals formed, but this will take a few weeks, so let's actually talk about the laboratory chemistry behind it. So first what we did was dissolved aluminum, preferably about a gram, so then you can measure it out and be able to get results as in percent yield and stuff like that, into a basic solution of 4 molar potassium hydroxide. And so what you get is KALOH4, and this will be used later on. But what you want to do, because some solids will precipitate out from that, is you want to be able to vacuum filter the solids out to get the, there's some impurities and then plus the solids. And so you're going to use the KALOH4, and you're going to dissolve that into 9, or you're going to use 9 molar sulfuric acid per se, and dissolve that into the KALOH4. And so what this is going to do is it's going to neutralize the basic potassium hydroxide. And so some will precipitate out right away, but you don't want that, so you're going to use the remainder set amount of sulfuric acid, and you're going to dump that into the already sulfuric acid and KALOH4 solution, and this will dissolve the rest of them, and then this is what you're looking for. And then so after that you're going to do an ice bath, and the ice bath is crucial to the whole process, because what it does is it slows the movement of molecules down and allows it to form in a crystalline structure, and so the original alum is able to precipitate out. And then so your final product of the precipitate is the alum, and that is KALSO42 with 12 hydrates attached to it. So after all of this, you have alum, and you want to rinse it out and then recrystallize it. And these are very simple steps. And so to rinse it out, you're just going to filter. There's going to be some solution. You're going to filter that solution. You're going to filter it again. Then you're going to rinse it out with a 50-50 ethanol H2O solution. And so then you're able on to recrystallization. And this is a pretty easy process. As I said, you're just going to make a 40 milliliter alum solution with deionized water and your solid alum crystals. And so what you're going to do is you're just going to make a very heavily saturated solution, and you're going to heat and stir, because heat allows for more to be able to be dissolved into the solution. And so this whole thing, what the recrystallization does is it allows for the crystals to grow larger and larger, and so this is where we're able to visually observe large crystals, and you can kind of see the shapes that it takes when it's in its fullest. And so you could also do this to other salts, as in sodium chloride or NaCl. And so that's pretty much the same process on how to do that. You just saturate a solution of NaCl and water, preferably boiling water, so that you're able to dissolve more. And then you put it, you just stir until there's solids being visibly going to the bottom. That means it's fully saturated. Then you're going to place it somewhere where it can dissolve slowly, and the crystals are able to grow and not be touched or messed with too much. And so what I found on YouTube and just WikiHow is to make another solution is to super saturate a solution. This is just out of any crystal base of your choice, and you're going to let it sit overnight with some filter over the top of whatever bowl you use, and then it's going to evaporate a little bit and then have some small crystals form. Then you use this crystal, tie a little piece of fish wire or something, place it in another super saturated solution, and let that sit. And what you will get is a very large crystal, which then again you will be able to observe its shape and or qualities. And so that right there is how we made the alum solution, and I will report back in the next few weeks as crystals begin to form.